let's keep it a little bit simpler. Let's say father puts this M, and for a lot of household expenses and all that stuff, okay, and remaining money, he just want to allocate to his children. Okay, so suppose child one. Okay, again, by the way, I'm assuming right now that child one only cares about what child one gets. Child two only cares about what child two gets. Okay, and of course, we have this. Okay, let's keep things simple for the time being. This. Okay, so they only care about the money that they have, and their satisfaction level is just linear in the money. Okay, and father's utility is a function of u1, u2, okay, and m. Okay, uf, u1, u2, m is equal to 100 root m, okay, fine, plus min u1, u2. And yes, so now we can solve this problem, which is maximize with respect to m, m1, m2, okay, 100 root m plus min, okay, m1, m2, okay, and the constraint is m1 plus m2 plus m is equal to some capital M. That's what he has. Is this clear? So it's a 3-variable optimization problem. Okay, you can just call this father's care model. Okay, that was mother's love model. This is father's care model. Okay, fine. Okay, now let me tell you how to approach this. So let's just think about it. Just think from the father's perspective. I mean, so clearly, father will never want M1 to be less than M2 or M2 to be less than M1. So clearly, M1 will always equal M2. This is the problem. M1 will always equal M2 in optimum. Do you agree? Yes or no? M1 cannot be less than M2. M1 cannot be greater than M2. The standard argument applies that if M1 is less than M2, then father can always take a little bit amount out of M2 and put it in M1, and the minimum will go up, right? And the smaller of the two will go up. So what that means is that it will never happen that either M1 is less than M2 or M1 is greater than M2 in optimum. So that means M1 will always equal M2 in such a case in optimum. Okay, what that means is what that means is father can actually write this problem in this way: 100 root m plus m1, because m1 is always equal to m2, so you can remove m2. Min m1 m2 will always be m1. Yes, because m1 equals m2 means what? Or you can write m2 whatever you wish, doesn't matter. Okay, and clearly m1, because m2 equals m1, so this will be 2m1, okay, plus m equals capital M. Is this fine? Okay, now this is a standard quasi-linear utility maximization problem that you can easily solve. Okay, please note that I'm assuming it's not a intertemporal model. Okay, if you have an intertemporal model, father may have other considerations like saving for the children, okay, and the family, for future needs, saving for the retirement and etc., whatever, a lot of planning. Okay, so we can always make this model dynamic, with all those things in mind, and clearly, there's a lot to do in that. I mean, we can make this as more as interesting as we can. So, this one, but this is kind of a simple model, static model, where father has this much money and this is what he cares for. Is this fine? Okay. Have you understood this? Okay, so you can just solve this problem. Okay, and this is a standard quasi-linear case. I think I must have solved this on YouTube also. Okay, this is L2.19. Okay, and I give you 15 minutes. Watch this video, solve this problem properly. Okay, for every value of capital M, find the solution to this problem. Because capital M is obviously the amount of money that the father has to spend on household necessities and the pocket monies. So what you have to do is you just have to figure out, just solve this problem, maximize this subject to this constraint, and then figure out the solution. What you can do is you can watch this video. This is another example of how to solve quasi-linear. Why don't you just solve this problem for 1 lakh? Yeah, so I mean, all that you have to do is just a standard utility maximization problem. Okay, you solve it and you want to get so it turns out that 1 lakh is sufficiently large income. So if you just equate the slopes, you're going to get this 50 by root m is equal to half. Okay, because the price of m is 1, price of m1 is 2. Okay, and then you just have to solve the standard thing. So this is 100 equals root m, so m equals 10,000. Okay, so if m is 10,000, then m1 is 45,000, and that's same as m2. Okay, so according to this model, this specific model, 10,000 is the minimum requirement for the household. Once that is met, rest is all for children. Okay, and then the father divides whatever is the remaining for the child's need. For obviously in this particular model, the present needs. In more realistic, more general model, it could be future needs as well. So whatever. Okay, so is this clear? Okay, excellent.